Hi ladies and gentlemen, in the last classes we designed some combinational circuits and you simulated them with the QX. Now in this video I tell you about another hardware description tool, that's a hardware description language, that is Verilog, the various simulation tools for that, and some basics of the Verilog. So let me start with that presentation. The speech is organized into your learning outcomes, the overview of hardware description languages, what do these HDLs do, the types of HDLs, why we prefer Verilog to other hardware description languages, the simulation with Verilog, the simulation tools used with Verilog, and your summary of your what you learned. What you will learn in this course, in this video, is that you will learn about hardware description languages and their names. You will compare hardware description languages with software like other programming languages like C, etc. You will learn the advantages in using Verilog, and you will learn the simulation tools for Verilog and the method of installation. Now, when you come to the overview of HDL, you are familiar with programming languages such as C, that does general purpose computing. In the last semester, you learned C programming. In such languages, you do not bother about the hardware that performs operations. Like if you want to do an AND operation or an addition operation, it simply does the operation. The compiler does the operation, and you never bother about what hardware that performs the operation. But hardware description languages, unlike software, they are designed to model digital circuit. It is clearly specified which hardware is used for doing some computation. It is used to model the digital circuits. So moreover, HDL statements are executed in parallel. In C programming or other programming languages, you see that when you run the code, the instructions are executed in a sequence. Sequentially, they are executed. While in the case of HDL statements, these statements are executed in parallel. You know that in actual digital circuits, if you look back at your previous circuits you designed, you can see that some gates receive inputs in parallel, and they work in parallel. So HDL statements are also executed in parallel. Now, simulation and synthesis of logic circuits done with HDL. HDLs are widely used in conjunction with FPGAs. FPGAs are field programmable gate arrays. That is where you actually create the circuit. That is where you make the actual hardware. So you have full performance FPGAs like Vortex, etc. But in this course, we will be using some low-end FPGAs like tiny FPGAs, low-cost open source FPGAs like tiny FPGA, lattice boards, etc. So what do HDLs do? They do the simulation and synthesis. If you look into this block diagram, there's a simulation. First, it performs a simulation. This is just checks the functional correctness of the circuit you designed, and then it does a synthesis. What actually it does is it decides what connections are there, or it creates a connectivity file or something called a netlist. Just like you synthesized a logic circuit from a truth table in the previous classes, it decides the connections between different nodes. And these netlists are placed and routed to an FPGA using some place and route tools like Arachne, FPGA tool, etc. There are many open tools available, and finally the board is tested in real time. There are two. When you come to the types of HDL, there are two languages. One is Verilog and the other is VHDL. VHDL is acronym for Very High Speed Integrated Circuit Hardware Description Language, and Verilog is a commercial name. Verilog came to the scene in 1983. And the reason why we prefer Verilog to VHDL is there are four reasons why we put Verilog in the syllabus rather than VHDL. The first reason is the syntax is very similar to C, which you studied in the previous semester. So even though the two are two things, C is a programming language and Verilog is a hardware description language, the syntax is somewhat similar. So it will be easier for a beginner student. So second reason why we prefer Verilog is that it's a loosely typed language and it is easier for a beginner because the type mismatches are very less in Verilog, and it is less frustrating for a beginner. So the third reason why we choose Verilog is that there are many open source tools for place and route with Verilog than VHDL. So you may be working with many open source tiny FPGA like tiny FPGA boards, etc. So you can use many open tools for writing this netlist into the tiny FPGA. So with VHDL there are very few tools for few open tools. So the advantage with open tools is that you can purchase an FPGA for around 2,000 rupees or as low as 1,500 rupees, and some tiny FPGA boards come at around 4,000 rupees. So you can buy one such board, and even at home you can do this. You don't have to spend any money on the software for writing this netlist to the FPGA. So the fourth reason why we use Verilog is the majority of industries use Verilog. It is very easy to do prototyping in Verilog, design in Verilog. So it increases your job opportunities in the industry. Then simulation with Verilog, simulation actually tests the functional correctness of the circuit designed, and the tool I use in this course is iCarus Verilog. This iVerilog can be installed in Ubuntu with the command sudo apt-get install iVerilog. You go to the terminal or shell, and you simply type sudo apt-get install iVerilog and give the root password, and the iVerilog package will be installed from the Ubuntu repositories. Or you can download some exe files or Microsoft installer files from SourceForge and install in Windows. And the simulated circuit can be tested with something called a test bench. First I write a Verilog code, and you perform a simulation, and you know that it is functionally correct. Then you have to test it with some signal. So what you do is I write another Verilog code called a Verilog test bench, and this Verilog test bench can create in a VCD file or a value change dump file. These are actually waveforms which you can see on a waveform viewer. So the waveform viewer, the open waveform viewer that you use is a GTK wave. So the GTK wave is installed with this command sudo apt-get install GTK wave. That is also available in the Ubuntu repository. Go to the terminal, type sudo apt-get install GTK wave and give the root password, and it will be installed from the Ubuntu repository. Now I come to the end of this session. The summary is that you learned about hardware description languages and their names. You compared the HDLs with the software. Then you understood the rationale in using Verilog. Then you understood the simulation tools for Verilog and the methods of installation. And there I come to the end of this session, and I thank you all.